Hi everyone, in this video we will learn how to find the direction and the magnitude of the components of a vector. So the components of a vector is the effect of a vector in a particular direction. So how do we determine the direction of a vector? So we need to start from the tail of the resultant vector. So this is the tail and this is the head. So we need to start from the tail and we need to reach the head. And the vectors, the components, are set at right angles to each other to simplify the calculations. So here, the x component, we will start from the tail, and the x component, the horizontal component, will be directed to the right. And the y components, is it going to be upwards or downwards? If we want to create a right angle triangle, the direction of the vertical component must be upwards. So since the resultant vector is force, which equals to 10 newtons, then the horizontal component will be Fx and the vertical component will be Fy. And as we can see here, we have a right angle triangle, and the x component and the y components, as we can see here, are connected from head to tail. Okay, so now how do we find the value of Fx? So we can use SOHCAHTOA because here we have a right angle triangle, and using SOHCAHTOA we can find Fx and Fy. So let's start with Fx. We know the hypotenuse and you want to find the adjacent side, so therefore we will use KA. So let's write here SOHCAHTOA. So we know the value of hypotenuse and you want to find the value of the adjacent side, and therefore we will use cos ratio to find Fx. So cos 60 equals adjacent, which is Fx, over the hypotenuse, which is 10. So here Fx is the adjacent side, is next to 60 degrees, and hypotenuse equals 10 newtons. And therefore Fx equals, multiply both sides by 10, we get 10 cos 60. And now we can use the calculator to determine the value of Fx. So 10 times cos 60 equals 5 newtons. And from the diagram, we know that Fx is to the right. So we can write here east, 5 newtons east. Now let's find the value of Fy. So you know the hypotenuse and you want to find the opposite side. So we have h and we want to find O, and therefore we will use sine ratio to find the value of Fy. So sine theta, sine 60 equals opposite, which is Fy, over hypotenuse, which is 10. And therefore Fy equals 10 times sine 60. So 10 times sine 60 is equal to 8.7 newtons, and we know Fy is acting upwards, so we can say north. So therefore Fx equals to 5 newtons east. This is the horizontal component, and the vertical component, which is Fy, equals 10 sine 60. Okay, so what can we conclude from here? If the unknown is opposite to the angle, then that unknown, so for example Fy is opposite to 60 degrees, then Fy equals hypotenuse times sine theta, so 10 sine 60. And if the unknown is next to the angle, then that unknown equals hypotenuse times cos 60. So Fx equals hypotenuse cos 60, 10 cos 60. Alright, so now let's look at the next example, part B. So we have to start from the tail of the vector. So the x component is to the right and the vertical component is downwards. So for the x component, the horizontal component, you can write it as fx or fh, h for horizontal. So let's write it now as f horizontal to find the horizontal component, and we can also find the vertical component, f vertical. So again, connect the vectors from head to tail, okay? And now we can use sine, cos, and tan ratios to find the missing sides. So here, f horizontal is next to the angle, so f horizontal equals hypotenuse cos theta. So 15 cos 50. So therefore, fh equals, let's calculate the value of fh, 15 cos 50 equals 9.64 newtons. And f vertical equals, so f vertical is opposite to the angle, so we have to use sine ratio. So sine 50 equals fv over 15. So fv equals hypotenuse, which is 15 times sine theta. And therefore f vertical equals 15 sine 50 equals 11.49 newtons. So the magnitude of f horizontal is 9.64 newtons, and from the diagram we can see that f horizontal is to the right, so we can write here east for the direction of f horizontal, and the direction of f vertical is downwards, so we can write here south. We can also go down first and then move to the right. But in this case, you would need to use angle 40 degrees. 90 minus 50 equals to 40 degrees. And the answer would work as well. So in this case, let's also find it using the blue triangle. So here, f vertical, as we can see, is also downward, and f horizontal is to the right. Okay? So therefore, if you calculate f vertical here, f vertical would equal to, so f vertical is next to the angle, so we have to use hypotenuse cos theta. So we have 15 cos 40, and the answer must be the same as this answer, which is 11.49 newtons downwards. And f horizontal in this case is opposite to the angle, so we have to use sine ratio. Sine 40 equals f horizontal over the hypotenuse over 15. So f horizontal equals 15 times sine 40. And f horizontal must be equal to 9.64 newtons. And f horizontal is to the right. So we can write here east. So if you apply the resultant force on the object, or the horizontal component and vertical component of a vector on the object, the effect will be the same. Question 2. A truck is traveling at 20 meters per second along a straight road in a direction south 30 degrees west. Calculate the horizontal and vertical components of the velocity. So in this case, I know the resultant velocity, which equals to 20 meters per second. And I also know the direction of this velocity, which is south 30 degrees west. So now let's find the magnitude and direction of the horizontal and vertical components of the velocity. So in this case, we will start from the tail of the resultant vector, and the vertical component will be downwards, so we can move down first, or you can move to the left. Both answers are correct. And the x component will be to the left. So as we can see here, the components are connected from head to tail. So now let's find Vy and Vx. Alright, so velocity in the y direction and velocity in the x direction. So let's start with Vx. Vx is opposite to the angle, so we have to use sine ratio. So sine 30 equals opposite, which is Vx, over hypotenuse, which equals to 20, and therefore Vx equals 20 sine 30. So Vx is equal to, let's use the calculator, 20 sine 30 is equal to 10 meters per second. And from the vector diagram, we can see that Vy is downwards. So the direction is south. And now let's find the value of Vy. So we can use cos ratio because you know the hypotenuse and you want to find the adjacent side. So therefore, cos 30 equals adjacent over hypotenuse. Adjacent is equal to Vy in this case, and hypotenuse is 20. So now we need to find the unknown Vy. So we can multiply both sides by 20. Vy will equal to 20 times cos 30, and 20 cos 30 is equal to 17.32. So Vy equals 17.32. Don't forget the units. Since the resultant vector is in meters per second, then Vy will also be in meters per second, and the direction is west.